Thanks. Hi, everyone. I'm Pratyush. I'm a PhD candidate at Johns Hopkins, but I also lead cryptography at Big Whale Labs. And today I'll be talking about some of our work on anonymous credentials in the real world. OK. So the first thing is, what are credentials, right? Let's set some background. So imagine you're going to a nice Ethereum Denver after party with your friends, right? You're standing in front of the nightclub, and then you go up to the bouncer, and then you show them your ID, right? And so what information does your ID have? It has basically a lot of information about you, where you live, your address, your exact date of birth, things like that. But the only thing that the person who's checking your ID at a nightclub or many such events like that need is what your age is, right? Actually, they only need to know that you're over 21. They don't even need to know your exact age. So how does anonymous credentials help us here, right? So the point is that we're trying to prove certain facts about our identity, and we want to control how fine-grained the information is that we're working with, right? So perhaps the thing that you want to prove is that someone is just over 21 years of age, or they live in the state of Colorado, but you don't want to reveal your address, like all of the other information about you. And right now, the way it works is that credentials are usually issued from these trusted agencies like the government, and you have to give them a lot of information. So can we do something better in this on-chain world where we have a lot of activity on our addresses? Maybe we can use it in some way and add anonymous credential badges to our Ethereum addresses and so on, right? So, yeah. So how do we have any type of issuers like in the blockchain world, right? So zero-knowledge proofs sort of allow this nice property that anyone can now be an issuer, right? So I'm going to walk through an example to talk about this. So imagine that you're trying to create a Discord group for all the holders of a particular NFT collection, right? So let's say Bored Apes. And how would you implement anonymous credentials for this? You know all the addresses of the people who own Bored Apes, and that's public information on-chain. And if I am an issuer, I can grab all of this public information, and then I do the following, right? I add anyone who produces a following zero-knowledge proof to the Discord, right? So I communicate with them on Telegram. I don't know who they are in the real world. I don't even know their address. They just send me a zero-knowledge proof, which says the following, right? The proof attests to the fact that I own one of the addresses from the list of all addresses that have at least one Bored Ape, right? And so the way this proof works is that you have a huge Merkle tree which has all the addresses which someone draws from a public blockchain on the holders of a particular NFT. And then you create a zero-knowledge proof of membership for one of the addresses. And then perhaps you sign a message using that address, and all of this information is checked inside a zero-knowledge proof, right? Or you just say that you own the keys to that address, and the relationship between the public key and private key is then computed within the zero-knowledge proof, right? So the keys are fully hidden. You don't know the address of the person, yet you find out that they actually do own one of the addresses which has this particular collection, right? OK. But yeah, this is based on the fact that, OK, you can check the keys. So you check this relationship that here I talked about on the private key, how it maps to the public key and the address. And this information is checked inside the zero-knowledge proof. But again, this checks the private key information. Yes, it's cool. But the problem is that if you look at wallets today, all of the major wallets, they're not going to expose your private keys to an external proving system, which perhaps operates on your browser. So imagine a web app that's trying to help you generate such a proof based on your MetaMask wallet or any other popular wallet. They won't be able to do so because your private keys won't be exposed, so you won't be able to input them into your proof circuit, right? So the best we can actually do here is we can just create signatures on a challenge message, right? So what the prover here is the owner of an NFT in the collection. What they're going to do is they'll ask for a challenge from the verifier. Of course, all of this happens non-interactively behind the scenes. But imagine the verifier sends a random challenge, and the verifier is like, if you can sign this message from any of the addresses in this whole list and create a proof for that, then I'm good. Then I'm convinced that you actually own one of those addresses, right? So again, we're in the same world, but we're creating a different proof now. The proof says that I can sign as one of the addresses instead of saying that I own the private key, right? That is not the relationship that we can check because wallets do not expose private keys. So we just check that a particular signature, which is on a challenge message, can actually be produced by whoever the prover is, right? So this gives us this nice proof system now where any verifier can verify this certain fact about you, which is that if you own an NFT in a particular collection, right? And I'll give more examples for why something like this can be amazing as an anonymous credential, right? Right, so I already talked through all of this. Yeah, so the security here sort of relies on this proof of knowledge of signature, that you know a signature on the particular challenge verifier message, right? If you can actually use your private keys, then the proof relies on the knowledge of keys, which is a stronger proof, right? So we have worked out like the security of such a scheme, and we are convinced to the best of our knowledge that this is a good proof system to use for such an anonymous credential, right? But bad things can still happen in a system. So for example, if the verifier message is something that someone else has already signed before and somehow they can get access to that signature, they can fake an anonymous credential without owning one of those NFTs. So again, this verifier challenge message has to be random enough, and people shouldn't be out there signing it in the wild just so others cannot obtain this signature and spoof an anonymous credential, right? So how fast are these sort of anonymous credential generations, right? So we have some CIRCOM numbers here. So based on our implementation, we're able to get CIRCOM constraints around 600,000, plus minus maybe 50,000. It takes a few minutes to generate the proof on your browser. The proof size is small, and you can verify it efficiently. Yeah, and there's other proof systems which are Rust-based. Perhaps doing them, using them in browsers is perhaps a bit more challenging, but they have achieved better results from this proof system called Spartan, which is a bit newer, but also a great proof system. Yeah. And then, okay, so we have these proof systems, but where are these anonymous credentials actually helpful, right? So credential-based access is everywhere, right? If you sign on to an exchange to do any activity, the KYC checks your age or nationality. Maybe there's an allow list, a ban list of like people from certain nations are banned from accessing it. But it is still unnecessarily intrusive. For example, imagine a DeFi platform wants only US users to be able to access their platform. They still ask you for all of your information, your passport, everything, your date of birth, your address, right? And there's also, perhaps like deploying zero-knowledge proofs for KYC is a very high-stakes problem, right? Because if things go bad, you can end up in things where you violate legal things and you get in legal trouble. So a nice place to try these things out and fix all the bugs is to access socials, right? So imagine you have a group, a social media group, which is fully anonymous, but you allow people to form small groups based on their pedigree. So maybe certain universities, maybe a group for employees of like a big employer so they can speak freely about the problems they have at their place of work, maybe for founders and VCs, or maybe you have these anonymous credentials that are based on your real-world expertise. So whether if you're a medical professional or a lawyer who has actually passed the bar somewhere, or things like that, right? So why should we care about this, right? It looks cool, but there are so many instances where freedom and expression and your actual safety is at odds. I'm sure you've heard of a lot of journalists who break stories which put their lives in danger. There's also people who have jobs where if they speak badly about their employer, they'll risk losing their job, but they still want to speak about some wrongdoing, right? So anonymous reviews and anonymous social media platforms can help you in these situations, right? And so one final thing I wanted to talk about, which is another anonymous credential system that we've come up with, is it's called proofs of email ownership. So what are we trying to prove here? What we're trying to attest to is that someone who has a particular public key or an address also owns an email address that ends in a particular domain. So for example, I'm using the @xyz.com domain here. So you have an address, you have an email, you're just trying to say that person who has one of the emails in this domain owns this particular address, right? So it's kind of like a certificate. There has been some recent work in the past on this stuff. It's called Blind Certificate Authorities. It was a paper at Oakland S&P in 2019. It's a nice paper, but it has certain flaws, which is perhaps one of the reasons why it hasn't been deployed at large. But basically, it requires your email client to have a particular specification. And so let's say your employer doesn't want you to use this proof system. They can just make sure that the email client that you're using doesn't follow that specification, and then you won't be able to use the proof system proposed in this paper, right? And if this is not the case, you can still use the proof system, but you need the technical expertise to set up your own mail server. And this would prevent most people from using it, because setting up your own mail server is a pain in the ass. Like, I mean, yeah, just. Okay, so the proof of account ownership is this protocol which is based on something called secure channel injection. I'm not going to go into too many details here, but it allows whoever is your verifier that wants to check that you own an @xyz.com domain, they're going to insert a particular message in your communication to your SMTP server. And if the prover can extract that challenge, then the verifier knows that you own like one of the emails in that particular domain, right? Which is their protocol. Okay. We've come up with a protocol which we're calling Primo in the paper we're writing, but it allows you to attest to the fact that someone who has a particular public key, which is based on the Ethereum address public key, owns an email address with an @xyz domain. And so how do we do with this? Our ideas are basically motivated by having very simple UX, and it's based on the idea of anonymity sets. And the reason we do this is because one simple thing that everyone has access to, no matter where you work, is one, you can read the emails which are associated with your email address, and the second thing is you would know the email addresses of a bunch of your colleagues who have the same domain email, right? So all we ask is that you grab all of your, maybe a few of the email addresses from the same domain, and then we have certain decentralized attesters. You can have multiple such attesters, but we base our cryptography on this two-attester non-collusion assumption, which is that two attesters will not collude and create fake proofs. And then the attesters send challenge tokens to all of these email addresses, and then you can mint an ERC 1155 token based on the knowledge of the things that the attester sends you, right? And the nice property is that even if the person who has full control over your email server sees you receiving messages, well, first of all, they'll see the same message being received by a huge group of people, so your anonymity won't be violated beyond this set ever. So the view is consistent statistically, so not even based on a cryptographic assumption. And the second thing is that once you can create these proofs by yourself, and you can have attesters. Anyone can be an attester. We will be releasing all of this code publicly, so anyone can act as the attester and run these attesters themselves, so you don't have to depend on us. And one common criticism that people have is that, oh, like what if someone just starts banning people from receiving attester messages? Well, since anyone can act as an attester, there's no constant attester email address to ban, right? Yeah. And we have extremely simple UX. The only thing we require people to be able to do is use a wallet and use their email. So anyone who knows how to do these things can use our proof system, and our performance is significantly better in terms of the proof size and verification time. Another very important feature that we have is that we can combine multiple email domains. So for example, imagine that we are trying to come up with a proof system that proves to someone that you work at a popular venture capital firm, right? And so let's say we decide on a list of 100 top VC firms, and then we combine all of the email domains, and the person just proves that they own one of the emails out of the 100 email domains which are associated with VCs, right? And this feature is unique to our proving system compared to blind certificate authorities. Okay, yeah, that's it. And we're experimenting with these socials, for anonymous credentials that we've built for founders and VCs, and you can sign up for a wait list here. And there's also my Twitter handle. Yeah, awesome. Thanks.
We'll just have actually one very short question while our next speaker comes up to send everyone. Oh, yeah, you can ask well.
Okay, so have you seen about the idea of directly verifying the DKIM signature? So you don't need a tester for the pro email ownership.
Sorry, what was that? I didn't get the question.
So basically, like you send an email to the receiver will check the DKIM signature to know that this is an email from you with a certain body of the email, right? That actually is an easy way to do the pro email ownership without requiring a tester. That's the idea we can think about, DKIM.
Yeah. I mean, if you're saying that people can do entropy-based analysis and ban these emails, you can always use some steganographic techniques to prevent that. But having a tester sometimes is useful, especially when you're trying to mint tokens based on this aspect, because there will be someone who runs like this smart contract, right?